Well, good morning, everybody. I hope you're doing well today. Today we're talking about the perception of the size of the Earth. Just how far is the horizon? So, how far is the horizon over the ocean? Some experts have told me it's about 6 miles, 10 kilometers. If I look up on Google, it shows many websites that also say the same thing, 6 miles or 10 kilometers. I drew this circle on Google Maps. I made the circle 10 miles. If you see down here, it's kind of small, but I made the circle 10 miles just to make sure it's big enough, and I didn't want to cheat the horizon any. So if you look at this part of the circle here out over the ocean, that is where the horizon would be. I picked this point. I just picked a point at random on the coast of California. You can see it's south of Half Moon Bay, San Gregorio Pescadero, in case you want to look that up. So this is what the horizon is like. Okay. So now let's zoom all the way out to the size of the Earth. So this is still Google Maps. It's the same everything. The only thing I did is zoom out. And if you look right there, I don't know if I can do it because I'm shaking. Right there, that yellow spot, that's that 10-mile horizon. So I think you can see why when we say that the horizon looks, the ocean looks flat, it's because we're only seeing just a very, very, very tiny spot on the Earth, the curvature of the Earth. I don't know if you've heard about this, but I've heard several different videos talking about the record photo for ground to ground distance. Many flat earthers quote this photo as proof of no curvature. If you look it up on Google, it was taken starting at the peak of Pic de Finstreras in the Pyrenees Mountains at a height of 9,272 feet, which is 2,820 meters. The destination peak where they went to was 275 miles away, 443 kilometers distant, and that peak was Pic Gaspard. It is at 12,730 feet, which is 3,880 meters in the French Alps. So those are the numbers. You want to plug those into the Metabunk calculator. We can do that. 275 miles distance. The average viewer in feet is 9,277. I added 5 feet because of the height of the view of the person. We did it in imperial units. That's what I'm used to. So the distance was 275 miles. View height 1.676 miles, and you can read the rest of that. So if we use standard refraction just means they've taken an average adjustment just for the calculation. So if we look down here, the refracted hidden amount is 2.36 miles, which works out to be 12,447 feet. So if we look back at our numbers that we had in the previous slide, the peak was 12,730 feet, which leaves us 283 feet visible. Even over 275 miles, there's still 283 feet visible. This down here is a quote I took from the authors, the people that actually took the picture. It says, refractive favorable circumstances allowed to view some other peaks, even that more distant than the Barre de Écrins. Pic Gaspard, 443 kilometers, is what has given us this time the brand new world record distance of photographed landscapes of our planet. So even the photographers that took the picture say that it was because refraction was very favorable. Here is their drawing that illustrates, so you have the viewer height here, camera, the horizon dip, so there's the horizon, but we're up here, line of sight, so the amount visible is this green line, the green line there. So you can see there's quite a bit of it visible. Let me see if no, okay. Here is the geographic picture of the distance. Shows you what they were seeing. Here's a diagram also that they drew, showing here's the peak, the curvature of the earth, and the distant peak. I also drew this in Google Earth, so here is the first peak, and over here is the second peak, Pic de Gaspard. So you can see it was quite a bit of distance. And once again, what I want to do is zoom out. So there is that incredible distance, 443 kilometers, which again, it is pretty big compared to our first one, but still it's a very small distance compared to the size of the Earth. So our perception of sizes, you can see from the photos that what we see as a large distance doesn't compare to the size of the Earth. Where's the curve? The Earth is huge. Even the record long distance photo fits with the curve calculator and is small compared to the size of the Earth. The distance that you can see depends greatly on your equipment. By the way, those guys had a 1200 times telescope. Depends on the viewer height, the distance, the height of the distant object. But the greatest factor that they had that you would have on how far and how much you can see is atmospheric and ground conditions. There are all kinds of things that you have to take into account: temperature, barometric pressure, humidity, and many other things. Remember, this photo was taken at a very high altitude. So I want to ask the flat earthers a question. Here goes. Where's the flat?